Hi, let's talk about populating next right pointers in each node. So you're given a perfect binary tree. So you have the struct node. So you have val, left, right, and then next. And then basically you just have to point your current node to the next one in the current level. And if you're on the last node, right, just point at the node. So using this idea and then using the breadth search method, you will probably solve this question pretty simple. So I'm going to check if the root is actually equal to no. If that is true, then you just return no. Doesn't matter, right? And for example 2, like you have to return a no, right? And then I will have to create a queue to store every single node in this current level. So queue no queue equal to new linked list. And I also need a dummy node, so I can, when I return, I can actually return the root right away. So I'm using the dummy to traverse. So q.offer dummy. So while q is not empty, and also I need to know my current size. The current size is actually the current level, the number of nodes in the current level. So q.size, and at the end I also need the pre. So I would say equal to no first, and then pre is actually keep remember the the previous one, and then you will just point at the current node, right? So I will traverse the size of the current level of the tree, so less than size, and then I plus plus. So I will say no, and then this will be no equal to q.poll. So the current poll tree node, the node will be the one you have to check. If this I is equal to 0, then there's nothing to point to the next one, right? So I will just assign pre equal to no, and then if that is not the first one, I will say pre.next is equal to the current node, and then pre will have to reassign to the node. So every single time you will just switch your pre to your current node when you assign the next, right? And at the end, I will have to assign pre.next equal to no. So I will actually set the current next to the node. But I also need to check for the children. So if no.left is not no, and I will just say q.offer no.left. And also if no.right is not no, I will just assign q.offer no.right. And this will be the solution. So let me just run it and then see if I have any missing or not. Alright, I didn't miss anything. So here we go. So let's talk about the time and space complexity. For the time, you traverse every single one of them, right? This will cost you all of them. And then space, I would say it's all of them because you have to put into your queue and then pop and then push, offer, sorry. And then that will cost all of them for sure. For every single level, you have to push in, offer into your queue for sure. So time and space are all of them. And then I will see you next time. Bye.